This particular figure is demonstrating autosomal recessive inheritance. And one of the common characteristics in autosomal recessive inheritance is you'll have generations of unaffected individuals that come back to ultimately produce an affected individual. And the affected individual sort of pops out in the pedigree. And the reason for that is that they're carriers that have moved from generation to generation, and just by probability, an affected offspring hasn't been produced. So remember, if we're starting with an autosomal recessive disorder, we always start with the individual who's affected. Now, in this particular pedigree, they're only showing you one affected individual, so it's pretty easy. We know that this individual would have to be homozygous recessive. Now, remember, the slash indicates this individual has died. Most likely, the implication is has died as a result of the genetic situation associated with this particular phenotype. So if this individual is affected, then we know that these two individuals, individuals 5-1 and 5-2, must have been carriers. And if individuals 5-1 and 5-2 are carriers, then can we assign genotypes to individuals 6-2, 3, and 4? So if you do your pedigree, or excuse me, do your Punnett square for a heterozygote times a heterozygote, you get 4 possibilities, right? A homozygous dominant, 2 heterozygotes, and a homozygous recessive. Now remember, the homozygous recessive is not an option for these 3 individuals because they're not shaded in. So that means that there are 3 options left. One of the 3 is homozygous dominant, 2 of the 3 is heterozygous. So we can't definitively say what their genotype was. So we would just put simply a dominant A with a slash or an underscore after it to indicate that it could be homozygous dominant or it could be heterozygous. But if we were forced into making a decision, we would want to predict what the odds would dictate, which is there's a 2/3 chance that the individuals are heterozygous, while there's only a 1/3 chance that the individual is homozygous dominant. So we could keep that in mind if push came to shove. Now, working our way back up beyond this, our assumption is, the safest assumption is that recessive allele has been carried down through the generations from the original parents, because you notice there's an element of inbreeding in this pedigree. In other words, we can trace these 2 individuals back to common ancestors. And so it's more likely that the recessive allele came through this pedigree rather than coming into the pedigree from an unrelated individual. So if we follow that line of thinking then individual 4-1 would be heterozygous, while this particular individual we don't know. The individual could be heterozygous or it could be homozygous recessive. We just don't, or excuse me, homozygous dominant. We don't have a way of knowing for sure. But our guess is probably this one was carrying the allele, which meant that individual 3-2 was carrying the allele, which meant that individual 2-1 was carrying the allele, which means that individual 1-1 or 1-2, either both of them had to be carriers or at least one of them had to be a carrier. So there's a lot of possibilities in terms of what things could be in this particular pedigree. It's not as easy to nail it down because of these generations of unaffected individuals. But again, we can be rock solid in our certainty that individuals 5-1 and 5-2 had to have been heterozygous. Again, if we follow that line of thinking, we would suspect that individuals 4-3 was heterozygous, individual 3-3 was heterozygous, individual 2-3 was heterozygous, again, coming from either one or both of these parents being heterozygous as well.